What was the clue again? I think it was tan of pi minus x is equal to negative tan x. Is that right? Okay, good. So, they give you a clue. Now, by the way, you always need to look at a clue very closely. You need to stare at it, right? You need to think about what in the clue has any import or usefulness to the question I've got, right? Now, for me, there is one outstanding thing that's similar between the clue and the question. Does anyone see it? One outstanding thing. It's the pi minus, isn't it? Pi minus x. Here's a pi minus blah. But it doesn't matter that it's messy. It's just that it happens to be long to right. So the question is, how can I use this? Clearly, if I have an angle of some kind here, and tan of that angle is going to be relevant, right? Then I need to take tan of both sides somehow, okay? Now, here's one of the useful things for you, which I sort of glossed over before. We talked about the problems with doing this, sine of sine inverse, right? We said this was only equal to x when? Between -1 and 1, right? Because that's the restriction, that's where sine inverse exists, right? But when you come to tan, tan is different, right? When you think about tan of tan inverse, you think about what's the equivalent of this for tan inverse, and the answer is tan inverse exists for all real values. So you don't have a problem here. It's equal to x for all real values of x. So therefore, I can be a little more fast and loose with tan, right? I can just take tan of both sides, and it'll be okay, right? Now, here's the thing though. I cannot take tan of both sides here because this is what I'm trying to prove. Okay? So I can't just say, oh, here's my starting point, and then off I go, because I will obviously end up with the right answer, even if what I start with is wrong. So instead I would say, I know semantically it doesn't seem like there's that big a deal, but I would say, consider, and then what I want to consider, I can't consider an equation. An equation is a statement. This equals that, right? So therefore, I will consider something which is relevant to this statement, but isn't a statement itself. For instance, something like this. Oops. Tan inverse 2. And pi minus this. Okay? Now, I can consider these separately, right? I can consider tan of this and tan of this. Okay? Is this all right? Furthermore, I can consider what the difference between them is. Okay, now I'm set up. This is the thing which I'm going to work with. Okay, so have a look piece by piece. What's this thing? This is double angle. This is tan to theta, x, whatever you want to call it. Okay, so what's double angle? It's 2 tan x, in this case, tan inverse of 2. Right? On 1 minus tan squared, isn't it? 1 minus tan squared of, there's my angle. Is that okay? Right. Now what's happening over here? Aha, there's my clue. Okay? So instead of writing that, I'm going to write this. Okay? So that is minus plus, because of the negative, right? Tan of, now what is the x? Right? In this clue, it corresponds to cos inverse of 3/5, does it not? Right? Let's see here. Cos inverse of 3/5. Okay, this guy on the left hand side, easy. What is this? 2 times 2. What's on the bottom? 1 minus 4, right? So this is -3. Is that okay? You content with that? So that'll be -4 and 3. What is this? Okay, well this is I can put this in a triangle, can't I? 3, 4, 5. Where's theta? Right? It's cos, so it's adjacent. It's this guy up here, right? So what's tan of that? It's 4 on 3. So now I've established that this thing is equal to 0. That this thing is equal to 0, right? Therefore, I can say those two are equal. Those two terms up there. That's equal to this. Okay, yes? And so on that basis, I can say, well, I don't need to worry about the tans anymore. If tan of the angle is the same, then the angles will also be the same. See what I've done? Okay. So I've sort of done a few different things here. Number one, I've thought very carefully about the clue and therefore what shape I need to put this in to use it. Secondly, you can't start with this equation and then go from there, even though it makes things a lot simpler. It doesn't hold water logically as a proof, okay? You have to consider something like this, which is not a statement of truth, work with it, and then draw your statement out from there. Make sense?